Welcome to my virtual class. My name is Omeri. Today I'll be introducing to you Unit 3, which is about waves. And Unit 3, as we're going to see, is going to cover properties of waves, the electromagnetic spectrum, light waves, and sound. For today, we shall be looking at the first unit, which is the properties of waves. First, we shall start by defining what is a wave. So, a wave is a transfer of energy. A wave refers to transfer of energy. We can also say that it is a transmission. A wave is a transmission of disturbance. A transmission of disturbance that involves transfer of energy. That is a wave. So the first thing we shall be looking at is to move on and see the types of waves. This longitudinal wave and transverse wave. That is very particular in this my e-learning class. So first, let's look at what is a wave here.
Waves. One of the first things we need to know about waves is there are two different types of wave. One shown here by waves in the sea, and the other one shown by sound waves. So how are they different? Well, first let's look at the sea waves. If we look at them represented with this slinky, we see that the vibrations are at 90 degrees or perpendicular to the direction of travel of the wave. These are called transverse waves, and examples of them are waves in water, waves on a string, or light waves. Now let's look at the sound waves again. Again, we see them represented by the slinky, but this time the direction of vibration is parallel to the direction of travel. These are called longitudinal waves, and the only example you really need to remember is sound. One really important thing to remember about waves is they only transfer energy from place to place, not any matter. And we can see that here by looking at a lovely rubber duck sat in a bath. As a wave goes through, the duck bobs up and down.
So what we have learned is that there are two types of waves, and one of these waves is longitudinal wave. This longitudinal wave is a wave whose particles move or vibrate parallel to the direction of wave travel. And an example of longitudinal wave is a sound wave. Sound waves. Number two is the transverse wave. Transverse wave. These are waves whose particles vibrate normally in the direction of wave travel. And an example of transverse wave is light waves. Light waves. This is what we have been able to look at. So we have longitudinal wave and transverse wave as main examples of types of waves here. So we want to proceed forward and look at the other part of these properties of waves in particular. So we look at what we are supposed to cover at the end of this. The end of this lesson, you should be able to distinguish between transverse and longitudinal wave. Define the terms amplitude, wavefront, frequency, wavelength, State the relationship between speed, wavelength, and frequency. Describe reflection and refraction of waves, and describe the Doppler effect. Now, these are my notes. You can be able to take these short notes as this video continues. You can be able to replay the video as you write down the notes. In particular, as I move forward, we'll be able to define what is a longitudinal wave. A longitudinal wave is a wave that vibrates alongside the direction in which the wave travels. The example of a longitudinal wave is a sound wave. So we'll be defining these key terms. The first term is amplitude. This is the maximum movement of particles from equilibrium position. Wavelength. This is the distance from crest to crest for a transverse wave. It is the distance from rarefaction to rarefaction for a longitudinal wave. I want to show you what is a rarefaction. This point is a rarefaction. Rarefaction. Then this point here is a compression. Compression is a point of high pressure, where rarefaction is a point of low pressure. Relationship between frequency and the periodic time. There's an equation that relates these two. The inverse of frequency is equal to periodic time t. So the product of t and f is equivalent to 1. Let us look at this question. Calculate the frequency of a wave whose period is 5 microseconds. So first we will be able to say that frequency is equivalent to 1 divided by the periodic time. 1 divided by the periodic time. Now, as you can be able to see that the periodic time is in microseconds, you change it to seconds first. Now, let me do this first example. Then you will do the rest of the questions as they are. 10 questions. I'll do number 1 and number 1 and number 7. So let me do the first question. So they want the frequency. First we'll be able to say that f is equivalent to, so f is equivalent to 1 over t, and our t is equal to 5 microseconds, which is equivalent to 5,000 seconds. Remember, always time should be in seconds. The periodic time should always be in seconds. So my frequency will be equal to 1 over 5,000. So this is Hertz. You can simplify this using a calculator. I will do number 7. This was question 1. So question 7. So my question 7 reads, calculate the period of a wave whose frequency is 500 Hz. So period t is equal to 1 over f. So be able to say my t is equal to 1 over f. My f is 500. Then this one, the answer will be in seconds. This is how to work out question 7. So this is the end of my lesson today. So your homework is these questions here. You do them. So once you have done this homework, please upload your answers to omeshtobias@gmail.com. You can upload your answers to omeshtobias@gmail.com. Then the marking and the revised copy will be sent back to you in a few minutes. So that's the end of my lesson. If you have a question, you can catch me in my live chat or on my caption here on this video. In our next lesson, we shall be starting the wave equation. My next lesson will be the wave equation. Thank you very much for being part of my virtual class. My name is Omeri Tobias.